In this try this problem, we're asked to verify that this given function defined over the given interval satisfies the conditions of Rolle's theorem. Then we're asked to find the points guaranteed by Rolle's theorem. And Rolle's theorem says basically that if there's a function and f of a and f of b have the same value, the same output, and the function is continuous and differentiable along the interval, then it must have a slope of 0 at some point. And you can see that the graph is going to have to turn around, or I guess it could be just a straight line. But if the beginning value and the end value are the same, then the graph, and it's continuous and differentiable, then it means that the graph has to make some turn at some point along the way. And you can see each of these examples. Here's the last example. It makes 2 turns to get back. It starts here, and to get back to that point, it has to make a turn somewhere along the way. In this case, it makes 2 turns, and at both of those points, the derivative is 0. All right, so here's an example. It says verify that the function f of x equals 2x squared minus 8x plus 6 over the interval from 1 to 3 satisfies the conditions of Rolle's theorem, and then find all points guaranteed by Rolle's theorem. So first off, let's see if it satisfies the conditions of Rolle's theorem. So we want to find f of 1, and we want to find f of 3, and we want to see if they are equal to one another. So f of 1 would be 2 times 1 squared minus 8 times 1 plus 6, and that equals 2 minus 8 gives you a negative 6, plus 6 is 0. And then f of 3 is going to be 2 times 3 squared minus 8 times 3 plus 6. And that is going to give you 2 times 9 is 18 minus 24 is going to give you negative 6 plus 6 is 0. Okay, so we see that f of 1 is equal to f of 3. And Rolle's theorem then guarantees that there is some point C, so there exists C, such that f prime of C equals 0. And so it asks us to find all points guaranteed by Rolle's theorem. So we know there's at least one. So let's go ahead and take the derivative of f of x, and we get 4x minus 8. And we can find the point at which f prime of c equals 0. And that happens at 4x equals 8 or x equals 2.